Okay, so let's talk about balancing equations. When we're balancing equations, we have to understand why we're balancing equations. And the reason why is because of the law of conservation of mass, which basically says mass cannot be created nor destroyed in a chemical equation. Whatever you have on the left, you have to have on the right. That's what we talked about, all the reactants and the products matching each other. So step number one is to write the skeleton equation. Okay, sometimes the skeleton equation will be written for you. Other times it'll be in a word form, and you'll have to actually create the compounds first. Okay, so our example here is H2 plus O2 yields H2O. And just the little underscores there, just open spaces for the coefficients. Okay, step number two is going to be to do the atomic inventory. All right, so when I do atomic inventory, I have my equation here. What I like to do is just draw a line vertically right down the arrow. So I separate everything left and right from products to reactants and products. Okay, and then I write down everything we have. We have hydrogen and we have oxygen. Okay, on the left, we have a subscript of 2 for hydrogen, so we have 2 hydrogens. We have the same for oxygen, so we have 2 oxygens. On the right, we have a subscript of 2 next to hydrogen, so we have 2 hydrogens. And there's nothing here, so it's just 1 oxygen. Okay, and that's your atomic inventory. You have to know where you're starting. Okay. Step number 3. Okay, you're going to change the coefficients, because essentially they're all 1 to begin with, to balance amount of each element on both sides. Okay, so there's a few rules that you have to follow here. First rule is never change or add subscripts. Okay, you could not change H2O to H2O2. Okay, it's not how that works because those are 2 different products. Okay, so you don't want to do that. And you couldn't change this to like H3O if you needed another hydrogen. Okay, rule number 2 is you never put coefficients in the middle of a formula. Okay, so again, if you needed to change water to H2O, okay, to get a second oxygen, coefficients have to be put in front of the formula because they count for the entire formula. Okay, so again, you don't want to do that. Step number 3, or sorry, rule number 3, if something is alone in an equation, balance it last. What I mean by that is, let's say we have Al plus O2 yields Al2O3, balance your oxygens first, okay? Because aluminum, you can put whatever number you need to in front of aluminum. So if you balance your oxygens and you look over to the right and you see that you have 7 aluminums, then you can just put a number 7 in front of aluminum. It's pretty simple, okay? So I would do those last, just because it makes things a lot easier in the end, okay? Next rule, if an element has more than one compound on the same side of the equation, do it last. This um, more often with like oxygen and hydrogen, things that are very, very common. Take an example. Okay, so let's say you have, I don't know, H2O plus H2SO4, something like that. I don't know. But you've got hydrogen and whatever it makes. You've got hydrogen in 2 different things, in 2 different compounds on the same side, on the reactant side of the equation. So we don't want to try to balance hydrogens first. We want to try to do that last, just to see what we come up with. Because a lot of times when you try to balance one and then you go to the other side, it really messes with you. So we want to do those last as well. Last one, if you have a polyatomic ion on both sides, okay, it is important that it has to be on both sides, all right? You can balance it as one entity. Let's say you have, nitrate on one side, some form of nitrate, it doesn't matter, we can make nitric acid, I guess, plus aluminum oxide, all right, and then that yields aluminum nitrate, and I don't know, we'll call it water. I don't really know what it makes, but it doesn't matter, okay? You have nitrate on the left, you have nitrate on the right. So instead of balancing nitrogens and oxygens, okay, we can just balance nitrates as one thing. So we have one nitrate over here, okay, because the NO3 is part of nitrate, and then you have 3 over here because you have your subscript of 3 outside of your nitrate. So you can balance polyatomic ions as one thing if they are on the same, or sorry, if they are exactly the same on both sides, okay? You can balance a nitrate with a nitrite, okay? You can't balance, if this was NO2, you couldn't do that because this is NO3, okay? Step number 4, so you make sure you follow all those rules while you're balancing these. Step number 4, you are going to, oh, sorry, I didn't even do the example. My fault. Let's erase this. Okay, so we have H2 plus O2 yields H2O. Got our inventory here. Okay, so what you're going to do is you're going to see that the only thing you have not balanced here is oxygen. So we're going to put a 2 in front of this oxygen because we want to get 2 oxygens to match the left side. Okay, so 1 times 2 is going to give us 2, so we put our 2 right there. Okay, now that gives us 2 oxygens, but it also changes our hydrogens because 2 times 2 is now 4. So now we have 4 hydrogens where we only had 2. So now our oxygens are good, but our hydrogens are out of whack. So what times 2 is going to give us 4? Well, that answer is 2. So again, 2 times 2 gives us 4. It doesn't change anything else. Okay, this is not attached to anything else, so it doesn't change anything else over here. Okay, so you have 4 and 4, 2 and 2, and there's your answer. Okay, and this coefficient is 1. You don't have to put a 1, but you can. Okay, so this is a balanced equation now. Right, it's pretty quick, pretty simple once you get the hang of it. It's bookkeeping, making sure that you're keeping things in line. Okay, and what I like to do, especially when we get bigger problems, is when you change something, like in this side right here, we put a 2 there to get oxygen straight away, and then that also changes to hydrogen. So what I like to do is immediately go to the hydrogens. Okay, I changed oxygen, it also changed hydrogen, so the next step I immediately go to hydrogen so I don't forget about it. Okay, once that's done, move on to step 4, which is making sure your coefficients are the lowest whole number ratio. Times when you get going, you'll end up with, you know, something that's everything's a multiple of 2, so you can just simplify it all. All right, and then step number 5, just like in math, check your work. So just give a once over. You know, do I have the same number of hydrogens on the left and the right? Do I have the same number of aluminums on the left and the right? Okay, just a quick count. Okay, and that is that's balancing equations. We'll talk about balancing combustion equations in the next video.